Example 3. Find the derivative of the function fx is cube root of natural log x. Now cube root of natural log x is nothing but natural log x, the entire thing power 3. So here we can use the chain rule by setting u to be natural log x. Therefore, du dx is 1 by x. Therefore, derivative of fx is derivative of cube root of natural log x, which is d by du of cube root of u times du dx. So that's where the chain is, right? So what is derivative of u to the power 1/3? That's what cube root of u is. Derivative of u to the power 1/3 is 1/3 u to the power negative 2/3 times what is du dx? Du dx is 1 by x. So this is nothing but 1 by 3 u to the power 2/3 in the denominator times 1 by x. U to the power 2/3 is nothing but cube root of u squared. So 1 by 3 cube root of u squared times 1 by x, which is same as 1 by 3 cube root of natural log x power 2 times 1 by x. Combining it all, 1 by 3x cube root of natural log x squared. Example 4. Find the derivative of fx, which is natural log of an expression cube root of x squared plus 5x plus 2, the entire thing by square root x squared plus 4. Look, we could call this u and proceed with chain rule as before. It will be quite complicated, right? I mean, it's doable, but why would we? We can address this question more easily by using properties of natural log. What is natural log of a quotient? It is natural log of the numerator minus natural log of the denominator. Look at the numerator, that's a cube root. That is that polynomial x squared plus 5x plus 2 power 1/3. Likewise, what is square root? Square root is power half of the polynomial. So now use the property, another property of natural log. The exponent of your argument comes down. So this is natural log of x squared plus 5x plus 2. 1/3 of that. Likewise, minus that half jumps out. Half natural log of x squared plus 4. In other words, natural log of this expression is the difference of two natural log expressions. So derivative of this expression is derivative of the first minus derivative of the second with respect to x. Now here we use chain rule simply. Remember, 1/3 is outside. Derivative of this requires chain rule. So the argument itself goes down and the numerator is derivative of your argument. Likewise here, derivative of natural log of an expression, the argument itself goes down times derivative of the argument. Simplify 2x plus 5 over 3 times x squared plus 5x plus 2. It should be a minus 2x over 2 times x squared plus 4. Okay, so this should be a minus. I made a mistake there. So that minus continues. Okay. Minus, and that should be a minus. All right, we got that done. Next, find the derivative of fx equals natural log of absolute value x. Note the absolute value function. What is absolute value of x? It is x for x greater equals 0 and absolute value x is negative x for x less than or equal to 0. Now this is important to remember. For x negative, absolute value is negative of x. Okay, so for a negative number, negative of a negative number is positive. That's what happens. So now absolute value x is argument of natural log. Okay, so we are not allowed equal 0. So x could be positive or x could be negative. What happens is when x is positive, absolute value x is itself. When x is negative, absolute value incorporates one more negative. That's what it is. So natural log of x and natural log of negative x. Now for x greater than 0, we already know the derivative. Natural derivative of natural log x is 1 by x. Well, what happens when x is negative? Well, you use the chain rule. Let u be negative x. If x is negative, u is positive. So derivative with respect to x of natural log negative x is derivative with respect to u of natural log u times derivative of u with respect to x. Well, derivative of natural log u is 1 over u. Derivative of u with respect to x is negative 1. So it is negative 1 over u. U itself is negative x and there is an additional negative 1. So overall it is 1 by x. That's correct. In other words, derivative of natural log of absolute value x. When it's positive, it's 1 over x. When it's negative, it's also 1 over x. So either way, for any x non-zero, derivative with respect to x of natural log x is 1 over x. Here is graph of absolute value natural log of absolute value x. Natural log of absolute value x. So the right hand part is natural log x, x positive. When you take its reflection, you get natural log of negative x. So together, this is the entire graph of natural log of absolute value x, which brings us to an important conclusion. Integration of 1 over x is natural log of absolute value x. This is important because your x could be in the negative side. Okay, so don't forget, integration of 1 over x is natural log of absolute value x plus a constant of integration. Okay, so very important, derivative of natural log of absolute value x is 1 over x. Therefore, integral of 1 over x is natural log of absolute value x. Okay. In other words, look at this. We have a complete formula now. Integral of x to the n dx is x raised to n plus 1 over n plus 1 plus c. This makes sense when n is not negative 1. That would be undefined, you see. If n were negative 1, this would be undefined. So this integral you obtain when n is not negative 1. But what happens when n is negative 1? When n is negative 1, x to the negative 1 is 1 over x. So integral of x to the negative 1 is natural log absolute value x. So that completes your formula integral x raised to n dx. Okay, plus c, because c is constant of integration.